So, next up on the agenda, Ron and I had the pleasure about a month ago of interviewing Dan Bricklin. And for those of you, I think everybody may know who Dan Bricklin is, but if you don't, Dan Bricklin was the co-creator of VisiCalc, where many people thought that was why we have the Apple II today. For as a matter of fact, it skyrocketed the sales on that, and him and Bob Frankston, were co-created it. The interview was very interesting. It ran a lot longer than Ron and I thought.
Yeah, I during the interview, I was like, he kept saying, "Are you sure? Is this going to run long?" And I'm like, "Yeah, it's going to run long, but these are the people that want to hear your story, so you run as long as you want." So, part one that we're going to do today is like an hour, and then part two is kind of the second, like the remainder part of the interview.
And what a story! And what a story it was! It was not only his time at VisiCorp when he was doing, programming VisiCalc, but he talked about, other things in his career. So it was just an awesome video and very interesting. So believe me, the hour will go by faster than you think it will here.
Oh,
so
yeah. Absolutely.
So I guess, should we roll the video, Ron?
Yeah, let's roll it. Let's get moving.
All right. Hey, everybody. Thanks for joining us here today. I'm Ron from Ron's Computers Videos, and I'm joined by
Jay from KansasFest.
Hey, Jay. Thanks for dragging me along today. This will be really, really great. As you can see, we've got a wonderful guest with us here, Dan Bricklin. Let me just go ahead and I'll give you a little bit of an introduction. It's our distinct honor to introduce a true pioneer of the personal computing revolution, Dan Bricklin. Often called the father of the electronic spreadsheet, Dan co-created VisiCalc, the first spreadsheet for personal computers. Launched in 1979, it turned the Apple II into a business tool and helped spark the PC revolution. Dan earned degrees from MIT and Harvard Business School. Beyond VisiCalc, Dan built a notable career as a software entrepreneur and author. He founded Software Garden, developed tools like NoteTaker HD, and became a thought leader in usability. His honors include the IEEE Computer Pioneer Award and inductions into the National Inventors Hall of Fame and the Computer History Museum. Please join us in giving a warm welcome to a true innovator and a legend in computing, Dan Bricklin. Dan, how are you today, sir?
Thanks. I'm doing good.
Is there anything I missed?
In your life you do lots of things, but that's good. That's maybe things will come up.
Yeah.
But, one's life covers lots of stuff, and different people care about different things.
Mm-hmm. Well, we certainly care about all the innovations and all the contributions you've made to the Apple II community. It's such an important part of like our lives, kind of growing up or in the hobby. And so we want to hear everything you have to say today. But we've got some great questions that Jay prepared ahead of time. Do you want us to just go ahead and launch into that?
That's fine with me. I'm here to answer questions and to give you what you want, address the things that you want me to address.
Great.
Well, great, Dan. So, VisiCalc is about to turn 46 years old here, I think, in October or so. So, can you take us back to the moment when the idea first came to you for VisiCalc, and what problem were you trying to solve?
Well, it sort of developed over time in that my background was in interactive computing, screen-based computing. By that point, that would be in 1978. At that point, I had was at Digital Equipment Corporation, had developed one of the first screen-based word processing systems. We had to invent something which we call the ruler, where you can put tabs and stuff like that. Everybody who was building word processors had to independently invent things and stuff like that, which ran on a PDP-8, which is a very minimal machine, and was involved in some hardware for that. I had worked at the Multics project. Multics is the operating system at MIT, and then a little bit of Bell Labs, but mainly at MIT, that then became, through Bell Labs, Unix and then Linux, which is what we use today for stuff. So I come from, and that was a time-sharing type system, but I had seen all sorts of stuff. I worked on computerized typesetting. In computerized typesetting, I helped make an editing system, and I got to see the type of editing systems that they used in those days. The real advanced ones for doing typesetting for ads which are kind of like PageMaker, except out in hardware and whatever, Harris 2200. And so I had been exposed to, I had seen Sketchpad, which is a very early influential piece of software and stuff. So I was into interactive computing. So then I wanted to get into business. I had learned a lot about computers and all by going to school, getting a degree in computer science, electrical engineering. So I figured, why not get a degree in business and learn how business works? So I can start with my friend Bob. We wanted to start a company together. And I luckily got into Harvard Business School, where they use the case method. The case method is where you read 3 cases a night. A case is printed out about 5 to 20 pages of a particular business situation with a lot of exhibits that sort of, have numbers and words and stuff like that laid out in ways that make sense. And you have to discuss it, and you discuss it in class with 80, 90 other people in the class. It's, in an amphitheater-like classroom. And they're big blackboards in front, and they write stuff in there. And, so I got to imagine. I knew about word processing, and I knew about doing numbers and putting them where you want and stuff like that. I knew about the mouse. I had all this background and about putting stuff for typesetting in places. And if you put all that together and you say, oh, you're sitting in class, and somebody, I had also implemented a little bit of helping implement a little bit of BASIC, a little bit of a Lisp system and stuff. And I had led the development of APL and been involved with the development of APL twice for the Multic system. I was involved in that. So I was used to interpreted systems. So if you take that together, interpreted systems that do 2 + 2 = 4 and stuff like that, and then you take word processing, word wrapping, and what you see is what you get. You sit in business class and you have numbers on the screen, on the blackboard, and you make them, and somebody said, well, whatever, instead of making this 15, how about if it's 16? Erase it. And anybody run the numbers for that? We all had a calculator. This is my calculator. This was my calculator. Yeah. I couldn't afford the HP one. I had the one
TI,
TI one, yeah. Mm-hmm. And so, I started thinking about word processing with numbers. And what I did was I'm sitting in the front row of it's, sort of like that. Yeah, you got one. And daydreaming about it. And I imagined that this had a ball on the back, which is how mice sort of worked in those days with a rolling ball. If you remember the old mice.
Oh, yeah.
And this has enough keys to be able to do shifts, to be able to do alphabetics. And, there's a sum button over here and stuff like that. And I imagined it had a head-up display, which we now call augmented reality, where you can sort of see things at the same time you're looking at other people. And I imagined being able to type in some numbers and being able to circle it to select a range and then push the sum button, and I'd see the answer, and I could negotiate with somebody, because we did negotiation, games with that. And, I would know the answer. I could change the numbers and stuff. So I had this idea of what would be an electronic spreadsheet. We used spreadsheet paper, which is paper for actually doing that stuff. Mm-hmm. And let's see if I have some of that here. And I moved it over. I could show you whatever, but what I wanted is, like, I worked on plain old paper a lot, where you can put things anywhere you want. And then I decided to actually prototype it, and sat down in a time sharing system, a DEC PDP-10 time sharing system, and started trying to figure out how to build this thing. And out of that came the rows and columns, the ABCD 1, 2, 3, 4, the stuff that we have today. This plus this, point to that, etc. Came up with that idea, wrote a specification for it, and my friend Bob Frankston actually programmed it. So that's where it came up with it. Does that cover enough? It's a lot to do.
Yeah.
Yeah. Interesting.
No, it's a great history. Something I've always been curious about is, with all the personal computers that were on the market in 1979, you had the TI-99, you get the TRS-80.
No, TI, not yet. TI,
Not yet?
No, there were 3 that you could buy easily that weren't kits and stuff.
Mm-hmm.
You could buy the TRS-80 Model 1, but there was no Model 2 or Model 3.
Right.
You could buy the Commodore PET, which had a cassette tape for input, and you could buy the Apple II. Okay, those were the 3 of the day that you could go into a store and buy and take home and plug in and use.
So of those 3, though, yeah. Why did you pick the Apple II?
So what happened is, when I was trying to figure out if this is a useful thing or not, I went to some of my professors, and tried to explain to them what I was thinking about. This is spring of 1978, and I went to my first person I went to was my I wanted to go to my finance professor, but he was busy. So I went to my professor who did operations, manufacturing and stuff like that, and try to explain it. He said, well, you're talking about something, maybe you could use a modem or whatever. Do you know that people fly in every week from companies? They fly into one office and they have blackboards that go from room to room, and they run the numbers to be able to do material resource planning, MRP. And how much of this I'm going to use, and where you sell this many, I need this many of these and this many of those. And if you could do it with a modem at a distance, that would be really great, save a lot. Maybe this is an interesting thing. Then I went to my accounting professor. His name was Jim Cash, like money. Okay. And Jim turns out had a master's in computer science, not just a doctorate in management or whatever, but big guy. He had played basketball in college, and I think may have been in the NBA for a little bit, but decided this is what he was going to do. And I explained it to him. He said, Dan, I don't fully visualize what you're trying to do. He was good to say that, because that's true. Almost nobody, if you explained it to them. But you're talking about the human interface, and that's important. So you should do this thing, because the human interface is important. Jim went on to be the head of the Harvard's MBA program. There's a building named after him, Cash House. He's now retired emeritus. He was the first tenured Black professor at Harvard Business School. He was on the board of Walmart, General Electric, Microsoft. He was, he knew what he was talking about and all that stuff. So I got some good advice with that. And he gave other advice to me over time. But then I finally got to see my professor of finance. And I went down to see him, and I said, Charlie, here's what I'm thinking of doing. Real estate agents can do. And he said, he's looking up from his listings from printouts from Fortran programs or something. He said, Dan, there already are financial forecasting tools. Why would anybody want yours and run on a personal computer? But I have a second-year student. You're a first-year student. I have a second-year student. His name is Dan Filestra, and he's working with personal computers, and he's trying to sell software for it. And he'll tell you why real estate agents won't buy personal computer to do your thing. And that's how I met Dan Filestra. Personal Software was the name of the company.
Yeah.
Personal Software became, at the time, one of the largest, if not the largest, it was up there with Microsoft maybe at the time, sellers of prepackaged personal computer software. They sort of came in a baggie with a cassette or something like that. They sold, the big killer app was MicroChess that they sold, and some other stuff. And Dan, being an MBA, he understood that this, I explained about this thing, and he said, you should do it for an Apple II. You should do it for a personal computer. I was thinking of building this thing for some mini computer-y type of thing. But you should do it and he really loved Apple. I think he got pre-Apple. He may have gotten pre-public stock in Apple. When his company was growing, he got some of the same board members in the same PR agency as Apple. He moved out to Mountain View from being in the Boston area. And he told us, he said, look, we're obviously going to put it on all 3 of the computers, because that's what we do at the time. And then there's this new one coming out called the Atari 400 and 800. And we'll do it for that, but that wasn't available for about a year. But Apple looks like, as I remember him saying, they had made a deal with Sugar Associates, who made the floppy drives, to say, look, we want to buy every one you can. Can you give me all of the rest of the capacity you haven't, given out, promised this year? And Apple had the floppy disk drives, and the other manufacturers couldn't get floppy drives as much. They had to get it from Tandon or whatever, but they're not the main one, which was Sugar. So it said, so why not do it for Apple first? Because that would be probably better. Even though we would run off of a cassette, let's do it off of that. So we said, okay, we'll do it for the Apple first, and then we'll do it for the others later. I was still in school. Bob would do the programming. My friend Bob Frankston would do the programming. He had done a little bit of programming for personal software, and he knew the 6502 chip. In fact, we had access on the Multic system. We had access to an assembler and linker and stuff that we could use on the time sharing system and then download for testing. And that's how we actually built the first one. So Bob had worked for a company called ECD that made a board computer or something that was pretty advanced, but I don't know if they ever shipped it or whatever. It was a competitor to the Apple II. So he was familiar with programming in machine language, the 6502 chip. So why not start with that? So all of those things together, plus they had an extra Apple II for me to borrow and use and do a prototype. And in the fall of 1978 in BASIC, I think it might have been floating point BASIC, I built a prototype of what became VisiCalc. I had already figured out by using a time sharing system, ABCD 1, 2, 3, 4, etc. But I was going to be using a mouse. I wanted to use a mouse. There is no mouse on the Apple II. So I said, I'm going to use the paddles, right? Go out. I have an Apple II out in the garage. I should go get my paddles with that. Just got it out of my warehouse and put it in there so my grandchildren can have an Apple II. And I tried the paddles. And what I do is you would go left and right, and then you push the fire button, and then you would go up and down. Okay? Pretty cool. Well, but it used like an RC circuit in the way it didn't really have a pointer. I just could do cell, cell, cell. It wasn't very good to do that. It didn't feel right for my little prototype that I did. So, well, the Apple II has 2 arrow keys, left, right, hit the space bar instead of the fire button, up and down, right? And you have in the upper right corner, there's either an exclamation mark or a minus sign, which tells you which way you're going every time you hit it. And that's where I worked on the prototype. Initially, I had it make a sound as it calculated each recalculated cells. It went dink, 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 dink. So I found out that the dink sound was 3/4 of the time to do a recalc. So I got rid of the sound. That. So I did a prototype and then worked on the user interface, wrote a specification, and then Bob actually programmed it, took that same computer, borrowed it, put it in his attic using a modem to download what he did. He happened to have a terminal, a nice terminal from the job he had, and he wrote the code, almost all of the code. We eventually hired an employee who got finished things like getting divide working. I ended up writing the transcendental functions. Now we had this thing. You remember Byte magazine?
Oh yeah,
that was the big magazine back then. So Filestra was one of the head of our Filestra, Dan Filestra and Peter Jennings were the heads of the personal software. They would publish it, and we were the author, and they would pay us money and stuff like that. And they would actually manufacture it and sell it to stores. And Dan Filestra was one of the founding editors or something of Byte magazine, and a good friend of Carl Helmer's, who was the editor-in-chief. And so we showed it, early before it came out to Carl Helmer's. Carl in Byte magazine had a review of it before it came out in the summer of 1979. And he gave an example that he made up because he didn't have access to it because he couldn't get it. We had it, but we hadn't given out any beta copies yet for press to play with. And so he used transcendental functions since we told him we were going to have them. We didn't have them yet. You sine and cosine and you do this. Now we were thinking you'd be using it for doing like checkbooks and financial forecasting and stuff like that. But his example said we were going to have transcendental functions. So we had to have transcendental functions. So I had to go program that. And that fell to me. And I had given that problem. I happened to run into somebody, a guy by the name of Monty Davidoff. I ran into him and he said, hey, there's this book you can get that has all the algorithms, how to do that. I was at Microsoft summer intern, and that's what I used to do Microsoft basics. Yeah. If you get Bill Gates's most recent book, which you would, I highly recommend Bill's new book, Source Code, especially if you have to raise. It's about raising children. It's about raising difficult, challenging, very bright children. And he had great parents, great grandparents, and it's a wonderful book in terms of that. But in that, he talks about Monty and about that, and Monty's name's actually in the inside cover, on the listing, So there was there's connections there. And then we shipped it in the fall of 79, fall of 1979. Now, we were worried about piracy because people could just copy it, and and that was an issue back then with stuff. So one thing we realized that people would copy it. Well, the people at Personal Software developed some techniques that we could put on to make it hard to copy. They used some sectors that don't copyright, or I don't no idea, that we could do to make it harder to copy. But just in case, we felt what you do is you'd make a copy, you test it, it works, you give it to somebody. So what we did is we said, the Apple II drives, they have write protect. If you wrote on it, you probably don't have the write protect. So we'll just write on the disk all the time, okay? And that way you'll destroy it when you do it, okay? What we didn't know is that I guess Apple did not QA the disk, the read tab that well, that switch, or maybe it was flaky. I don't know. One of the people who had that problem was Steve Jobs using it. We got rid of that feature. Okay. So that's those are some of the stories from back then. We handmade the first I think 5 copies or so, and gave it to the first people who had actually paid for it. Mm-hmm. And that is and then it went out to computer stores. We got, let's see, it came, I don't know if I see it.
Yep, there it is.
Yeah. This is what it came in. This is a little later version. This is like a few months after, I think, but it looked like this, and it came on a floppy like this, with a card to send back and a reference card. And my father printed the reference card and stuff like that. There was a demo. Here's a demo disc. We sent demo discs out to computer stores. Computer stores could run the demo disc. It had basically macros that would play, that would make it do things. And so it could put some text up on the screen and actually run. And people actually, that's good. So the stores just put the monitor in the window and just had it auto running. And if you flipped it over the other side, it's one-sided disc, but we made it flip. The other side actually had a working copy. So some of them sold it, and I don't know. But what happened is, so that shipped in October 79. I think Spreadsheet Day is supposed to be the 17th of October or something, they say. That must have been the day when the first physical copy may have been manufactured and shipped, because I know that Personal Software got it, I think, the next day or so, or day after. I have a note in my logbooks about that. And then some Saturday, I think on a Saturday, the following Saturday, I got a physical copy, by overnight FedEx and stuff like that, Saturday delivery. And, it's gone from then. Computer store people told me the good ones learned that they would just ask somebody who came in what they did for business, and then ask them and then started a little bit maybe doing a spreadsheet for them. At that point, the person would take a credit card and stick it in their mouth and say, "Please take this. Take this." You know, how much is that, and what's all the hardware I need to run it?
Mm-hmm.
And those that learned to do that became very successful computer stores.
Yep.
There's one in Westport, Connecticut, that became extremely successful with that. That's what Cy Marin used to tell us how he sold it. People out here at the computer store, they became the number one Apple seller, I think, in the country. I had shown it to them early. Some of their employees joined Mitch Kapor later and helped found Lotus Development Corporation.
Mm-hmm.
They learned a lot about that. So that's some of the early days. That give you,
yeah, absolutely.
You know, and we didn't sell that many copies to begin with, but a lot for Apple. I mean, you know, we could tell how many Apples we're selling by how many copies of VisiCalc we're selling. You know, more or less, because we were like on every other machine or something. I don't know. And it just did better and better. And if you look at what Steve Jobs has said, there's video of him saying it. You know, if it weren't for VisiCalc, you'd be interviewing somebody else right now. You know, when I saw that video, it was done by WGBH. They have a nice interview with Steve, done in the 90s, where he talks about the early days and all that, and how important the disk drive was, because that's one of the reasons why we put VisiCalc on his machine.
Yeah. Mm-hmm.
If it weren't for that, he wouldn't have been Steve Jobs. Wouldn't have got to do what Steve Jobs did. Was what he said. So that's said that, you know. So that's pretty cool. And then we eventually put it on other machines. We put it on the Commodore PET. We did a translation of it into machine code for the TRS-80 and sold a lot for that, et cetera, et cetera. So.
Nice. So, well, speaking of Steve Jobs, Dan, did you end up ever working with Steve Jobs directly at Apple at all, and as part of the development process?
Our publisher, Personal Software, which moved out and later named themselves VisiCorp because they liked the name so much, they named the company after it, renamed the company after it. They were the interface to Apple. Okay. And so I would only meet Steve and Wazen. Those were the main people that I would meet initially at trade shows and stuff like that. I remember meeting Steve there, and definitely and meeting you know, Steve Jobs and Wozniak. And I mean, at later points, you know, I got to see, there was at one point, for various reasons, I ended up in a hotel room alone with Steve Jobs having dinner, just the two of us, which was, you know, kind of, it's a whole long story about that. But I've actually had dinner alone with Steve, you know, where they roll it in and stuff like that, at a trade show. And I did see Steve the last time he spoke, that Steve Jobs spoke at the WWDC, the Worldwide Developer Conference for Apple. So the last time he was at a public Apple event, I got to go over and say hi to him, and you know, one-on-one for a minute or two before he went over and went to see his wife, because he knew this was the last time he was going to be doing that. He was not well.
Yeah.
So, but I got to know the Apple III product manager, I think at the time, was Jeff Rakes, who then later on went to Microsoft. So I got to know him really well. We were on the board of the Software Publishers Association together. It was VisiCalc that convinced him that software was the thing to do. So that's why he ended up moving away from Apple and going to Microsoft, and then he ended up running the Gates Foundation, I think. So really good. There's some really good people who were in our industry back then. Some of the techies back then, you know, have been really good people for the world in many ways, and that's where their mind was at. You can learn what, you know, a lot of what was in Bill Gates's head by reading his book. He had a good writer working with him who did a lot of research. He would say in his book, like, I thought I remembered such and such, but when actually shown my report card, it wasn't all A's. You know? So, but whatever. It's interesting. When you read Bill's book, you hear about scrounging for computer time, like the one computer in the school type of thing, and how hard it was. And even at Harvard, how hard it was to get access and stuff. And in my case, I was able to get access to a computer at a school that was near me, a public school. I was at a private school, but my cousin David went to a public school that was one of the few in the whole school system in Philadelphia that had a time-sharing terminal. And I was able to learn there. And then I went to work at, I took a course, a National Science Foundation course at the University of Pennsylvania in the summer of 66, I think it was, 1966, or 67, maybe 67. And had a lot of access to computers. And then I worked at the Wharton School. After hours, after school, when I was in high school, I worked at the Wharton School at the University of Pennsylvania in their computational services. So I had access to big mainframes and stuff like that. And then I went to MIT where, through Project Mac working there, I had an infinite computing time with computers or whatever I wanted. So it was, you didn't have to scrounge. Early on, I had to scrounge. I mean, I had to beg the Bureau of Public Education in Philadelphia. I had to ask them, could I use your 1401 computer downtown that you use to do payroll? And they would stop payroll for a second to run on tapes.
Mm-hmm.
I have the tapes under there somewhere to run some of my programs as I was trying to do stuff and use their so that's when I was sort of scrounging for it. But by the time I got to college, it was really easy to get computing time and stuff.
Mm-hmm.
So those are like those days. And then personal computers started, becoming more normal. It was Ronald Reagan came out with a budget, and in the early 80s, I guess it was. And the Wall Street Journal had an article, an editorial, and they said, all over Washington, yellow legal pads and VisiCalc spreadsheets are trying to figure out about this. And they assumed you knew what VisiCalc was.
Mm-hmm.
And they assumed you used it. What they didn't know is when we developed VisiCalc, we wanted to make sure it worked like this thing, right? So therefore we used decimal base 100 actually, but basically decimal arithmetic, so that we would get the same type of numbers, not the 1.99999 or whatever, I mean, it would work the same way that you would get out of decimal arithmetic as opposed to binary arithmetic. And we had to figure out what was the maximum number of significant digits. It was, it was scientific notation, but how many digits do you need? So, and if you had too much, because we had to allocate, in various chunks, how much memory. It's done well. What would we possibly use this for? I mean, is anybody going to use it? Let's take, what's the biggest number? How about the budget of the United States of America in dollars? How many, what's that? And we figured out how many significant digits, and that's what we did. And it turned out that's what they used it for. You never know. You never know what's going to happen in this world about that. So,
funny.
You want any questions on that or anything else?
Yeah, actually, a follow-up.
As long as I wanted, and I got lots. So
yeah, I was going to say a follow-up on just what you said right there about the how many digits? How big do you make this? Where do you cut these things off? I mean, what were some of the biggest technical challenges that you and Bob Frankston faced when developing VisiCalc for the Apple II?
Okay.
I mean, would the limitations of the Apple II kind of restrict the design?
Yes. So why was that helpful? Well, first of all, because it didn't have a mouse, whatever, it got us the arrow keys, which meant you could just do whatever, and that was better. Okay. A mouse, it's still good to use an arrow keys, even though we have a mouse now. But one of the things about the Apple II is that the Apple II had 25 rows of 40 characters if you're in text mode.
Yep.
So you can't fit much on the screen. So we had to come up with things. We couldn't fit very much. So therefore had to come up with locked panes. We basically, titles. They call them locked panes today, but we call them titles, where you could lock the first row or two, and then scroll things through it, and you could still have that. And we allowed you to have two windows at the same time, and they could be synchronized. That if you scrolled in one window, you'd also scroll in the other window in the same direction or something like that. We had to develop that type of stuff so that you could work with huge spreadsheets. It handled, 63 columns by 256 rows was the max we could do. Not all of them at once, but you could go either 63 wide or 254 high. We could handle that much on the Apple II. You could put your totals up here and this, and you could change it there and get around because it was restricted. And that meant we could work with very big things where if we had a little bigger screen and restricted ourselves to the screen, we would have been much smaller. So it actually forced us to put in user interface. Now we're talking about a very small program. It ran in 32K. Okay, if you didn't use the, I think if you ran the tape version of it, the disc version did too, but you wouldn't have very much free memory. It had to be that every time you ran it, it used the same amount of memory. That required using a certain type of memory management. That if you, no matter what order you did something, if you did the same thing, you'd end up with the same size. Okay, so that therefore, if you saved it and you only had 3 bytes left when you saved it, when you came back and loaded it up again, you'd only have 3 bytes left. And we did that. And 123 ended up using a similar style of doing that. So a screenshot of today's VisiCalc is bigger in bytes than that was to fit all this stuff in there. That include the operating system and the screen buffer.
Wow.
If you think about it. Wow. Bob really, in order to be able to fit things in, every byte counted. So for example, if you hit slash, we wanted to have a help system, but there was no memory for a help system. But at least if you press slash, and which is the command for commands. I'm born with bent little fingers. I don't like hitting the control or shift key, so I couldn't reach an octave as a child. You hit slash, it would show you the letters that you could type as a prompt. And then if you typed one of the letters, it would show you the letters then. Well, it turned out that those letters that were then put on the screen were the same lookup table that were used, that when you type the letter would look it up in there. He didn't have a separate list for print, for displaying and for testing. I mean, as a programmer, you'll understand. Bob, he also wrote it using a macro assembler that it has almost no go-tos in it, even though it's in machine code. He did it all using macros that had if, then, else, and stuff like that to do the way you're supposed to do it without go-tos and stuff. The code had, shall we say, very few bugs. It was well tested by a lot of people, and we then actually, when we made the TRS-80 version of it, the listing would be the Apple version and the TRS-80 version, and the person who wrote that, the TRS-80 version, actually used the comments that were in the Apple II version. It was an almost idiomatic translation from one to the other. The IBM PC one also came out of the TRS-80 version of it, and that sold the most number of copies we sold was the IBM PC version.
Yeah. So when you're talking about your trials and tribulations that you and Bob had, was there ever a moment when you and Bob thought, oh my God, this might not work? And how did you overcome that?
I don't know. You have to have belief in what you're doing, and we knew it was useful. We didn't know how it would become this useful, so that we just thought, we had both done some stuff that was successful. I had done a word processing system that sold for 10, 15 years. The DeckMate, later it was sold as DeckMate. That was the original software for the cost 10. It was a PDP-8 and a desk. That was, I was project leader of that, and I wrote a goodly amount of the code. So I'm used to some stuff, but I knew that sometimes it doesn't work. Multics did not become very popular. Only a few Multics systems were sold. It was an incredible system. But out of it came Unix. Out of Unix came Linux, and the world runs on Unix and Linux, and Mac OS, and all that are all derivatives of the same thing. And if you knew Multics, you do some of the Multics commands, and the same things work in the later systems. So it's so you have to believe your program. I mean, everybody believes that their system's going to do really well, and you always think it's going to not do well, but you're scared about that, and you got to put this in it, you got to put that in it, you got to try this, you got to try, who knows? I mean, look at all the stuff we put in. We didn't need to put in. We didn't have to put in, double windows and all that. It still would have been useful. People would have put up with it. Wouldn't have been as good, but so.
VisiCalc's interface was pretty groundbreaking. How'd you decide on the grid-based structure and commands?
There's a video you can watch. It's on TED.com where I go into detail with visuals of it. But basically, I needed a way to be able to give you would be able to point to something, and the computer could put something into the formula that was readable by you to know what it is. Okay. And to do that, I ended up with a grid, A, B, C, D, 1, 2, 3, 4. And that did it. But then that let me have ranges of cells so that you can do, some from here to there and stuff like that. So because originally I expected to use a mouse and let it be free form. You could put things anywhere you want, because that's how we did text. It was not supposed to be a database. It's not columns and rows that are heterogeneous and stuff like that. It's, you put stuff where it makes sense to you, and the text is maybe part of it, or it may not be. And, you put, text and words and numbers, and, that's, you want to put, somewhere you're going to put a value here. This is a constant, but this is calculated. It just came about from what the idea of what I wanted to be able to do, and it had to be useful for business. And I had lots and lots of examples being in business school. I was the right person at the right time. There were lots of programmers, but they weren't in business school. And those that were not programmers who developed interactive computing stuff. Not many people developed interactive programs in those days. So, so I was the right person at the right time. And Bob had free time to be able to develop it and could afford to do it, to take the time off to do that.
Okay, well, yeah, that's awesome. But so you talked about all the features like the double windows and so forth in that. Were there any features that you wanted to include but couldn't because of the hardware limitations? And I guess a follow-up question to that, when you ported it to all of the other platforms, was there feature parity across that, or did the IBM, for example, have more features because you had more resources to work with?
There was so much we wanted to have in it. We would have liked to have had, natural order of recalc rather than, to go either across and down. But we realized that to do that, you needed more memory space, at least one more bit or something like that. And probably, you'd use a chain or something like that. And that we didn't have the memory space to do that. So we didn't program that in. Okay. We didn't have a help system. Well, of course we wanted a help system, in terms of that. Of course we wanted more functions. We would have liked upper lowercase, but Apple II didn't have upper lowercase. It wasn't until later versions and stuff like that. So there are all sorts of things. We did have macros, and there were companies that took advantage of it. That basically, when it saved the file, it basically saved the keystrokes necessary to recreate it. The greater than symbol meant go to, and then you would have the cell number, and then colon was like a carriage return. So it was like go to, A5, and then put the thing in carriage return. That is what the save was. Well, that was any input. So you could actually have macros, that were the keystrokes necessary to do whatever you want. And that way you can import all sorts of data. And there are companies that are still around today that got their start making interfaces to VisiCalc like that. And then, of course, we did start taking advantage of upper lowercase, more memory. But because of the difficulty of having a manual and all the documentation and everything like that, we tried to keep it all the same, because we ended up being on many, many different computers, of the day, and everybody kept coming to us and wanted to have it. So that's so like the IBM PC, we took advantage of more memory and stuff, but it basically is the same one. So if you get the IBM PC version that I put up, I got permission from the company that ended up buying our stuff. Lotus ended up buying our intellectual property, and then they were bought by IBM, and I got permission from IBM to be able to put a copy on my website, and I did that, and people downloaded it from there, and now it's available for like any Apple II, IBM PC emulator. They probably come with a copy of VisiCalc. It's not copy protected because one of our employees, David Reed, happened to save an uncopy protected copy, which I ended up having, and we ended up using that. David's one of the developers of, later on went to be one of the developers of the internet. Where was it at then or before then? The slash of TCP/IP, he's the slash.
Oh, wow.
And he wrote a very important, still important paper, and worked with us. As a close friend. So we came up with an advanced version, which we put on the Apple III, and then on the and then I think on an IBM PC and all that, VisiCalc advanced version. But by the time that actually could be on IBM and all that, 1.2.3 was coming out, and there were a whole lot of other issues, and it was pretty late for that. So, but to make the dock and all that the same, and it was just, and we all off of this similarly as much off of the same code base, so that the bugs are the same and stuff like that, so we could fix it. So it was good enough. I mean, it didn't have certain things. Everybody wanted commas and numbers, the 1,000 separators, and we wanted graphing. I had very simple graphing because you could, you could say, repeat this character whatever number of times the value is. So you could do bar graphs sort of sideways. And we wanted to do graphing, but of course we didn't. But 1.2.3 put in graphing because people wanted graphing. They put in commas, and they put in different width columns, not all the same. VisiCalc, you could change them, but they all had to be the same. And this, with 1.2.3, that was the main thing. People, when they heard about 1.2.3, said, does it have variable column widths? Does it have commas? If it does, I'll take it. Does it read VisiCalc files? Yes, it can read VisiCalc files. So that's helped 1.2.3, which was like the 50th spreadsheet or 30th or something. It was not the second, not after us. I think SuperCalc was the next one.
Yeah.
And and then of course after that there were various companies that tried using graphical user interface with it, and then Microsoft did really well with Excel, and they did Multiplan, but Multiplan they tried to be on all the same on every machine with the same software, and they used their environment that was restricted and how big it could be.
Yeah.
And 1.2.3 just ate their lunch by coding it specifically to the IBM PC, and then Lotus tried to develop this cool thing called Jazz, which was going to do everything. It'd be this and that and word processing, whatever. And Microsoft said, no, we'll just do the best damn spreadsheet we could. We'll call it Excel, and put it on the Mac and then on the PC, and it's held its own. It's a wonderful product.
VisiCalc is kind of credited as being the first killer app for kind of home personal computers outside of programming and things. And you spoke earlier when you sort of kind of realized that it was driving a lot of sales for Apple II. Did that get you any sort of special treatment inside Apple? I mean,
I don't know.
You talked about having dinner with Steve, but
I wouldn't know. I mean, Personal Software talked with them on it. I know they threatened to make their own copy, and with AppleWorks and stuff like that, eventually. But but I mean, I saw the Macintosh well before it was released. They came to us, And, so, I mean, that type of stuff. I saw the Apple III before. I remember having, an Apple III in my desk, it was in our secret room, which was behind a double door and whatever. And, one of the business press calling up saying, well, is Apple having this or is IBM having that? And so I don't know. I'm sitting on one of them. And we didn't ship the Apple III version. As I recall, I don't know if it's right. The Apple III, we finally okayed the Apple III version, and Apple, when we finally okayed it, Apple went public like the next day. They had been holding off.
Yeah.
So I don't know, because they needed to have, you had to have that VisiCalc on. IBM knew they had to have VisiCalc on their machine. They came to us and said, hey, can we have VisiCalc? We said, sure. We'll do whatever we can to do that. So, and converted and made a translation of the original code to make it run on the IBM PC. Mm-hmm. I think the person who did most of the conversion works on Outlook in Microsoft. He's still there.
Okay, rumor has it that Mitch Kapoor spent some time working at VisiCorp before launching Lotus.
Oh, yeah.
Yeah, what do you remember about his role and his contributions during that period? And did you have a sense that he might go on and create, something as impactful as Lotus at that point?
Oh, yeah. Let's see. Do I have any of his software up there? I have a copy of Microfinance System somewhere up there. I have. He was developing software back then, and I remember having dinner with him and Mr. Filestra of Personal Software, and when Dan was visiting from California after they had moved to Mountain View from or San Jose or whatever from Allston, Massachusetts, and he was saying to us, we really need a product manager for VisiCalc. This is really, and Mitch said, what about me? And so Mitch became the product manager for VisiCalc. So he knew all about the advanced versions we were working on, the features we were going to have. He knew all the competition. He knew more about the world of the spreadsheet market than most anybody in the world, probably, when he was there at Personal Software. And Personal Software raised some money from venture money or something, and then they were getting really tough with their authors, and we ended up in bad relationship with it. They ended up suing us, and we countersued them, whatever. But they finally said to Mitch, Mitch had made a product called VisiTrend and VisiPlot, which was a plotting type program that worked with VisiCalc, and they bought him out. He took the money, but he had a non-compete. So he wrote the non-compete. The non-compete, though, said he was allowed to make this product called Trio. Okay. And they didn't even look at probably the thing. And Trio was a spreadsheet combination with, graphic and word processing and database or whatever. He built 1, 2, 3. I remember him coming to me. I didn't know what he was doing, but he said, hey, Dan, any advice? I said, hire the best programmer you can. And he did. He hired this person we knew who had actually implemented spreadsheets a couple times. He had built a 2021, I think, or something. Had been a data general who we knew, who had been a housemate of the person who became my wife, this guy, John Sachs. And John wrote 1, 2, 3, and Mitch specified it. And Mitch called me over to see it, and I got to see it before they shipped. And I looked at it and said, wow, that's really cool. They're going to sell $60 million the first year. I was off by 10 million. Everybody else thought they were going to sell 10, but I got it pretty right. They were, there was a whole thing about that world. And Personal Software got really upset when they heard about that, and especially when one of their investors, Ben Rosen, who later became investor in Compaq and head of Compaq, the chairman of Compaq, Ben, invested in Lotus, and so they were real upset about that. But I remember telling Mr. Filestra at a thing, I said, look, I can't tell you. I've seen this thing. I can't tell you. But Mitch is working on something. And he said, Mitch is a nobody. Unfortunately, I told Mitch that. And Mitch wasn't a nobody. Mitch, obviously, I mean, all sorts of stuff in our industry and stuff. Co-founder of the Electronic Frontier Foundation and stuff like that. Mitch assembled like a dream team. The head of documentation and manufacturing and stuff was the person who was editor-in-chief of the McGraw-Hill magazines like Byte and stuff like that. He, Chris Morgan. He hired the top Apple salesman in the country from Computer Store to be his head of sales and stuff like that. John Sachs, who had implemented spreadsheets a few times, basically, as his programmer, who had been a data general and other places like that. And then Mitch had been product manager. He was a beta tester of a Multiplan. I think maybe the first time I saw Multiplan, or one of the first times, was when Mitch showed it to me. He put together an incredible team of incredible people. One of the top venture capitalists who also funded Compaq. So it was a dream team, and 1, 2, 3 became the dream product, and nobody was able to knock it off on a DOS machine. It was only Windows, which Lotus didn't go after. They didn't want to help Microsoft. They went after OS2 instead.
Yeah.
And so that's. And anyway, each time there's a new set of hardware and stuff like that, new operating systems and all, sometimes it's a time to change.
Well, how did competitors react when they first saw what VisiCalc can do, and why is imitation the most sincere form of flattery?
Well, there were competitors to Apple. They obviously wanted it. Okay, so everybody come and wanted it. So that's that's good, right? Except it meant that we had to develop a big company just to be able to put it on as many machines and do the thing of making them all the same, so we could use the same testing and the same documentation, etc. And we weren't advancing as far because we were doing the horizontal. I mean, as many as possible in terms of that. The competition, we looked at patenting, but in those days you couldn't patent software. We talked to lawyers about that. But in 1981, which is 2 years later, which is too late to patent, the Supreme Court said you could patent software. And so had we patented, we would have gone after people. We did go after people who did pirated it. Copyright law. We used copyright law and stuff like that. The world would not be better if we had done that. It would not have advanced as much. Mitch was willing to do things in the user interface that we weren't willing to do yet and stuff. And Microsoft was willing to do things that Lotus wasn't willing to do. Mm-hmm. So there are advantages that there weren't some of that. But there were lots of competition, but, you had to be on the right machines and, and everybody. Oh, like Microsoft, when they first came out with Multiplan, instead of using A1, A2, A3, they used R1, C1. Remember row 1, column 1, and whatever. Mm-hmm. Yeah. They used a very mathematical, techie way of doing things. Ridiculous. Of course, they had to go back and do what did Mitch do? Mitch said, we'll keep everything VisiCalc has that's good. And only when we have to do something different and we can do it better, will we do it better. And he did that. So it doesn't have variable columns. We'll put in variable columns. They're not willing to have labels that go long because there are issues about scrolling backwards. We'll put up with that. The glitches in that are okay. We'll put up with those glitches. So he was willing to make those trade-offs as a product manager and product developer, designer, in terms of that. So, that's so there were competitors when SuperCalc. I remember SuperCalc came out. I think Adam Osborne wanted VisiCalc on his Osborne 1. He wanted to bundle it with it, and he couldn't make a good deal with personal software. So he convinced this company called Sourcem. Sourcem is micros spelled backwards, to develop a product which became known as SuperCalc. I remember talking to some of the developers at a conference, and they didn't have some features, and I asked them, why don't they have that feature? They said, I don't know. Why would you need it? I told them, oh, okay, we'll add that feature. I mean, that happened all over the time. I remember, with Microsoft people looking at, oh, you have that feature in this product of yours, we can put that in multi-plan, and they did, and whatever. It was just, but there was a lot, everything was growing in those days, and it wasn't the money, it wasn't the same. I mean, I didn't become any, gazillionaire or anything like that out of this, which is unfortunate to a lot of schools and other places that would have Bricklin buildings and stuff like that, but they don't. This is the Bricklin building. It's my home. And that was even paid for by Dan Bricklin's demo program, a program that I did after VisiCalc.
I love that one.
Yeah, that was for the IBM PC. That was a real influential program. Got all sorts of awards for it. I have them up there. Best programming tool, beat out Microsoft and Borland with this prototyping tool. I wrote this Note Taker HD for the iPad. I wrote all the code for that. Yeah. I wrote all the code for demo, Dan Bricklin's demo program, and for Demo 2, and for a lot of other programs. Now and for the Macintosh stuff, the iPad stuff. Now I'm developing with some friends who run a company called Alpha Software Corporation. It's been around for many years. They had a product called Alpha 4, Alpha 5. Many might remember it from the 80s, the 90s, and whatever. Yeah. And they're still around. We still have Alpha Anywhere, and I'm in it's a business. It's business software for businesses to use to write their own applications. And the software I write is for data capture. It lets you use your phone disconnected from the internet and whatever, and be able to fill out forms that are very, very complex, and design those things and use them. And we're used in factories, around the world and stuff, like 24/7. They use my stuff. So I'm still developing software, but now mostly what I write is in JavaScript, and or had been Objective-C, and I guess I'll be writing in Swift soon. And I'm a little late with that, but we have AI to help you learn languages a lot and to program a lot easier. So it's the world is a little different than it used to be.
Well, I am enthralled.
Me too.
I can't wait for part 2.
I can't either, and that's coming up tomorrow. So it was a very interesting interview, and unfortunately, Dan will not be here to answer questions live. He is on vacation in Greenland, and Ron and I didn't want to strong arm him into answering questions. However, he did agree if we paste the questions into an email, he'll definitely answer them to the best of his ability to do so. So I'll gather the questions out of here later. And
or it's an amazing opportunity for us to have him back.
Yeah, exactly.
Do a KFest supplemental in a couple of months or something like that.
A third interview. Yeah, exactly. So
great.
All right.
Jay. Thanks, Jay, for having me along for the ride. I appreciate it.
It was awesome. It was awesome. And yeah, he has more stuff to talk about tomorrow, which is super interesting. A lot of it beyond VisiCalc. So the demo program, I used that a lot when we distributed software at Pitt. It's just unbelievable. So
thank you, sir.
All right. You are welcome.